Hi guys. We learned how to rationalize the denominator when it looks like this. For example, square root of 3 over square root of 5. There is nothing here in common, so I can divide them, like put them in one radical and then divide 3 and 5. There is nothing in common. But we learned that to rationalize the denominator of this fraction, we multiply this fraction with whatever is going to make that root 5 rational number. Root 5 is not rational because we don't know a number exactly. You multiply by itself, you get 5. So root 5 or radical 5 is called irrational number. This is a square root, so I need two 5s. I already have one, so I need one more. So I'm going to multiply by another square root of 5. Whatever you multiply the denominator with, you need to multiply the numerator with the same exact number. Now square root of 5 times square root of 5 is going to give you regular 5. So now it's rational number. The numerator is going to be square root 3 times 5, 15. But today we're going to learn how to rationalize the denominator if it looks different. It looks something like this. Square root of 5 minus 1, for example. And over here it doesn't matter what this number is. Now if we try the same idea and we say to rationalize this square root of 5, we multiply by another square root of 5 over square root of 5 as we did previously. Let's see what's going to happen. Now this is like parentheses here, and you need to multiply it by root 5. So that root 5 is going to distribute. So what we are going to get, square root of 5 times square root of 5, that's regular 5, which is good news. Now we have rational number. But we are not done with the multiplication. We can't stop now. We have to multiply the square root of 5 times the negative 1. So we negative square root of 5 is the answer. On the top is going to be 3 times square root of 5. So as we can see, still the denominator has that square root. It just flipped it was here at the beginning, now it's at the end. So now we didn't do anything. Still it's irrational number. Now if we remember from algebra 1, we learned something called difference of two squares. If we have, for example, x power 2 minus y power 2, this we call it difference of two squares. We learned that the factorization of this is x minus y, square root of the first, minus square root of the second, times square root of the first, plus square root of the second. So as you can see over here, when you multiply sum and difference, these we call them sum and difference. They look exactly the same. The only difference is one of them is sum and one of them is difference. When we multiply sum and difference of two binomials, we get two squares. And the good thing with the square, if this x is the square root of 5, then when we square it, we get regular 5. So this is, or this idea, or what we learned before, we can use it in here. So for example, if I have the same exact problem now and I want to rationalize the denominator, we are going to do this. I'm going to take the 3 over square root of 5 minus 1. Imagine this is your problem, you want to rationalize its denominator, and we multiply it by, this is the difference, so we multiply it by the sum. So we need to do it also to the numerator. So now when I multiply these two denominator, I get square of the first minus square of the second. Square of this minus square root of the second. So it's going to be square root of 5 squared minus then 1 squared. Always this is going to be minus. When you multiply sum and difference, always this is going to be in minus and these are going to be squares. Then we do the multiplication on the top. 3 times root 5, you distribute. You see, so right now we're using all the stuff we learned before. We're going to be using simplifying, we're using multiplication. All that stuff we learned, we need it now. So that's going to be 3 times square root of 5 plus 3 times 1 is 3. Now let's simplify the On the top there is nothing I can do, only this 3 is common factor. You see 3 and 3? So I can factor out this 3 one more time. Actually, I shouldn't do it from the beginning. I should just left it 3 times square root of 5 plus 1. On the bottom here, we're going to square the square root of 5, so it's square root of 5 times another square root of 5, so the answer is 5. Minus 1 squared, 1 times 1 is 1. So as you can see now, the denominator has no radical. So 5 minus 1 on the bottom is 4, and on the top we just can leave it either way. Either you leave it like that or you leave it like this. Usually we try to put it like that to make sure that there is no common factor between the numerator and whatever that number is. On this problem we don't have that. There is no common factor. I can't reduce 3 over 4. So I'm going to leave it like that. Now there is one more thing we need to know, that these two expressions, we call them conjugate to each other. Alright? So now what I just showed you as introduced to today's lesson, something called conjugates. I have shown you what conjugates are. So if we have two quantities like this, a square root of b plus c square root of d, and another quantity looks exactly the same. The only difference is the middle sign. If this is positive, the other one should be negative. If this is negative, the other one is positive. We call these two quantities here conjugates to each other. Like this quantity is conjugate to that, and this one is conjugate to the other. And we use this idea for the conjugates to get the difference of two squares, and we can rationalize the denominator in some special problems. So these two quantities are called conjugates of each other. So for example, square root of 3 plus square root of 5 and square root of 3 minus square root of 5, these are conjugates to each other. Also, 2 square root of 7 minus square root of 10, 2 square root of 7 plus square root of 10, we call them conjugate to each other. Square root of 6 minus 2, square root of 6 plus 2 are conjugates. They look exactly the same. The only difference is in the middle. One of them has to have negative in the middle and the other one has to have positive in the middle. 9 root 11 plus 4 square root of 3. 9 root 11 minus 4 square root of 3. These are conjugates. When we multiply two conjugates, we're going to get difference of two squares. So when we multiply two conjugates, this is TWO, so you don't make fun of me, guys. I know, you just wait for all my mistakes. Okay, so when we multiply two conjugates having radicals, the answer is rational number. Rational means no square root or no cubic root or stuff like that. And I did explain the difference of two squares. We went over this. We have seen example before. Here's another example. If I multiply 2 square root of 7 minus 10 by its conjugate, which is 2 square root of 7 plus 10, the answer is going to be difference of two squares. So it's square of the first minus square of the second. The first is 2 square root of 7. The second is this square root of 10. So now we square each one of them. So when I square root this, I'm doing 2 square root of 7 times another 2 square root of 7. 2 times 2 is 4. Square root of 7 times square root of 7 is going to be regular 7. So now I have 4 times 7. Over here, when I square the square root of 10, I get the number 10. 4 times 7, that's 28. 28 minus 10 is 18. That was another example when we multiply two conjugates. Now here's an example on how we're going to use conjugate to simplify, not to simplify. Yeah, we can say simplify, because remember when we say we have to simplify radicals, or any problem like your final answer cannot have radical in the denominator, and in this problem we have radical 5. To simplify over here means nothing inside the square root, you can take it out. That's one thing. If you remember the three conditions, we went over them before. If you have a fraction, the denominator of the fraction cannot have radicals. If you have a radical, you cannot have fraction inside the radical. That's second condition. So third condition, you can't have factor inside the radical which raised to power more than the index or equal to the index. So in this problem, we don't have anything here can be simplified inside the radicals, so that's one of the conditions. Inside the square root, we don't have fraction. The second condition is satisfied, but the problem itself looks like fraction and the denominator has radicals, so that's not the simplest form. So we need to get the conjugate of this and multiply it so we can simplify the problem. So I'm going to copy the problem one more time. 2 over square root of 5 minus 1 equal, we're going to write this fraction, the original fraction, then to rationalize the square root of 5 minus 1, you need to multiply it by the conjugate. If this is negative, I multiply by the same two things but positive in the middle. And whatever you do to the denominator, you have to do it there on the top, and then we do the multiplication. On the top, we need to multiply the 2 by the square root of 5 minus 1. So this is a quantity together, and I want to multiply it by 2, so we need to do the distributive property. 2 times root 5, here it is, 2 times 1. On the denominator, we have two quantities conjugate to each other, so the answer is going to be difference of two squares. Square of the first is the square root of 5, minus square of the second is number 1. Now when I square this square root of 5, is going to give me regular 5. Always when if it's square root of a number and you multiply it by itself, the answer is that original number without the radical. Don't put the radical again on the test and then you say, you're taking points because I just made a slight mistake, I put the radical. No, 5 is completely different than square root of 5. Then we square the 1. 1 times 1 is 1. 5 minus 1 is 4. On the top, I see over here 2's and I see 4, so I'm going to factor out the 2. So I'm going to write 2 and open parentheses. 2 times what is going to give you 2 square root of 5? 2 times the square root of 5. Plus 2 times what is going to give you 2? 2 times 1. If you want to check your work for factoring the 2, you multiply 2 times square root of 5. Here it is. 2 times 1 is 2, so everything is right. Now, 2 is a factor and this quantity is the other factor, over 4. When we simplify fraction, we can only cross out or divide by the factor. So I can divide both 2 and 4. Both of them is divisible by this 2. So I can say right now 2 divided by 2. I'm going to divide here by 2. I get 1. I divide this by 2. I get 2. So now the final answer is the square root of 5 plus 1 over 2. If this problem is on the test or the quiz and you just leave it over here and you don't proceed, that's not the simplest form because this fraction has a common factor. So you have to factor it out. Like if, for example, if times 2 square root of m minus 1, that also should be another parenthesis. So I have binomial times another binomial. FOIL, first times first, first times second, or outer. That's why we say FOIL, F for first times first, the O of the FOIL for the outer, outside, outside, then I, FOIL, F-O-I-L. I is for the inner, so I take these two inner and multiply them, and then last time the last. So it's going to be square root of m times 2 square root of m. Any square root times itself is going to give you a regular m. Like it's going to be square root of m squared, but later on it's going to be a regular m. It's up to you. You want to do it in 2 steps, it's alright. You want to do it right away, it's alright. So let me do it step by step so no one can get confused. So over here the outside is 1, invisible 1. On this one the outside is 2. So multiply the outside times the outside. The 1 times 2. This outside number, by the way, we call it the coefficient of the term. So the coefficient, if you want to talk mathematics, so that's coefficient. We don't say the outside. So coefficient times the coefficient. 1 times 2 is 2. And then square root of m times square root of m, you get square root of m squared. Square root of m times negative 1, you get negative square root of m. Then we distribute the negative 1. Negative 1 multiplied by 2 square root of m is going to be negative 2 square root of m. Negative 1 times another negative 1. Negative times negative is positive. 1 times 1 is 1. On the bottom, we're multiplying 2 conjugates. So it's going to give me difference of 2 squares. Square of the first minus square root of the second. So the first is 2 square root of m. I square that. Minus square of the second. 1 squared. Over here now we need to do the addition or combine, addition, subtraction, combine like terms. But even before that, we need also to simplify this one. Square root of m squared, that's going to be regular m, and don't forget the 2. So you write 2m. Don't write 2 square root of m. You lose point, you know that. These two are alike. Negative square root of m and negative 2 square root of m. They have the same radical. So you lost 1, then you lost 2, so actually you lost 3 of them. So you can combine these into one term, negative 3 square root of m. Then you bring down the plus 1. Now I need to square that. 2 times 2 is 4. Square root of m times another square root of m is regular m. Minus 1 squared is 1. Anything can be combined over here. I don't see like term. This is regular to m. I don't see any regular to m. This radical, we don't have any other radical look the same. 1 is a constant number, so actually nothing could be done, and that's the end of the problem. Thank you.